Okay, so compound inequality, two inequalities joined by and or. For an and compound inequality to be true, both inequalities are true. For an or to be true, just one must be true. And this really becomes most obvious when you're looking at the graph. For these inequalities, it's all about the graph. Okay. Go ahead, Hope. Can I go ahead? Yeah. So solve and graph. Here is a compound inequality that's tied, two inequalities tied together with an and. Right? So this is, let's solve this one first. What should I do? Subtract x. X is greater than 6. Okay? And, okay, solve this one. Add 7. X is less than 9. Again, you know, we started with a compound inequality tied together with an and, so you still got an and there. I mean, I'm careful to write that word there, right? Now, when I graph it, okay, on the number line, I need to have a 6, and I need to have a 9. Okay, for the 6, x greater than 6, is it open or closed circle? It's not or equal to. That means 6 actually does not solve this, right? So we say open circle. Do I shade it to the right or to the left? To the right. Right? Again, since x, the variable is solved on the left, this is pointing the direction of the shading. But in any case, it's greater than and greater than on the number line is to the right. Okay, do I need open or closed circle on 9? Open. Okay, and where does the shading go? Less than means to the left. Okay, in order for this to be true, both have to be true. Where on that graph are both of them true? Okay, everywhere in between 6 and 9, not just the whole numbers, right? Every real number in between 6 and 9 solves this. So the graph, that is the solution. And you can write in that with, you know, using these inequalities, you can say that that is your answer. However, much better, especially if you aspire to be good at this stuff, is you write 6 is less than x is less than 9. You make it a 3-part inequality, and that implies the and. It implies that 6 is less than x and x is less than 9. It's in between 6 and 9.